Cool, we're live. Hi guys, and welcome to my channel. It's been a while since I've made any videos. I've been asked by a friend if I can make a video or tutorial on how to use a multimeter. So today we're going to learn about what a multimeter is for dummies, and the basic things that we can use a multimeter for. I won't go into anything that's too technical. I'll refer to some terms that you may be familiar with, but I guess the important thing is that there was one time in my life that I didn't know how to use a multimeter, and I needed to learn how to use one, and my dad taught me how to use one. And if you don't know how to use one and you've got one lying around the house, then pick it up, and we'll try to teach you how to use it. So a multimeter is a digital multimeter is a test tool that's used to measure electrical values, volts, and voltage, current, amps, and resistance in ohms. You're going to need a multimeter, and you're going to need some leads. So you've got red and a black lead. There's the front of it there. And here's the side that plugs into the multimeter itself. For the purposes of our tests today, we're going to be plugging the red into the one that's got the V sign for voltage. That little headphone looking symbol is resistance, is to measure resistance or ohms. And then you've got a triangle with a cross through it. That's for measuring diodes. Your black one will go into the COM port here. Okay, I'm using a Fluke 179 true RMS multimeter. Most multimeters are the same. They'll have this dial around it, otherwise it may be a button style interface, but they all pretty much look the same. You'll have an off, then you've got your voltage. Okay, that's this one here is what we're going to be focusing more on, which is DC voltage or direct current. We'll jump into resistance as well very quickly, as well as capacitance, which is that orange one there. And then you'll see this one here, which is your diode test, and you've also got this sound looking symbol which allows you to test for continuity between one point and another. When you turn your multimeter on, turn it on so it's on the voltage symbol with the lines going through it. So those lines indicate that it's going to be detecting a DC voltage, and as you can see up here as well, it says that we're measuring in DC voltage. Auto range just means that we won't go into it, but it just it's basically an automatic setting to test within the high and the low ranges of voltage, but we won't worry about that. So with your test leads, what you can do is you can touch them together, okay, and that should zero them out before your first use. You don't have to always do that. There's a little light button here on mine. Not all multimeters have them, but they're a handy function. Let's get some batteries. So this battery that I have here is a 1.5 volt battery. Okay, we can see the polarity, which is the plus and the minus. So you don't want to get those mixed up, and if you weren't aware, the red goes to the positive or the plus sign, and the black goes to the negative. On a lot of multimeters you can cross the polarity, and it'll tell you basically that it's incorrect, and I'll show you how. It'll just show a minus sign in front of the reading. So we're testing a 1.5 volt battery. We better test it correctly first. And we're getting 1.448 volts. So if it's not reading at least 1.5 volts, then you've got to replace it. Okay, so we're getting 1.448 volts there, and we can tell it's in DC voltage. Now what happens if we turn this around? What I can tell you is that if you've done this on a proper electrical circuit, you could blow your multimeter up, could cause a fire. So always get into the habit of testing a circuit in the correct polarity. So we're going to do it in the incorrect polarity, and you'll see what happens. So we're getting minus 1448 volts, which just means that we need to flip the polarity, and that tells us that this side is indeed the plus sign, or the positive part of the terminal. Why this is important is because you'll get some batteries and you're unable to tell which side is the minus and which side is the positive sides, because it's either not written on there. So this is where this function comes in handy. So I got it lucky. I got a lucky go the first shot. So this side here is the positive, even though the wire is black. So never ever be never look at the colors of wires and trust them, because they could be wrong. A red wire could go to earth, and a black wire could go to 240 volts. You know, you could really hurt yourself. So we've found the plus and the minus. We can tell that this is a 3.7 battery, 3.7 volt battery. We can test this 9 volt battery here. So these 9 volt batteries usually have their polarity on them as well. And another good way to remember the polarity in a 9 volt battery, if they don't have the stickers, is that the larger one will always be the negative side. So we'll test this. So for a 9 volt battery, we're getting 6.96 volts, which is way under. So that battery will not work. I'll try another 9 volt battery. So this one is reading 1 volts, so that's definitely dead. Okay, we'll move over to a resistor, if I can find one. Okay. So this is a common resistor found in electrical circuits. They are quite small. You can tell what the resistance is based on the color codes. I'll show you this under the microscope. Okay, so we're able to tell what value this resistor is by getting all the colors. So that one would be brown, green, yellow, and gold. So with your resistors that look like this, the metallic gold or the silver will always be the last value read. So it would be, again, brown, green, yellow, gold. So if we put that into a calculator, a 4-band calculator, we're able to find out the resistance of that resistor. But we're going to go ahead and test ourselves. And we will switch this over to resistance. We'll get the resistor. And we'll just test one side. If this was on a board, you can just press it down on the board, the contacts. So this is a 450 ohm resistor. Well, that's what this is actually measuring. So it's measuring 450 ohms. And we're able to tell if that's correct by checking the 4-band color code. Put it into a calculator and it'll tell us what the true value is. If those values are different, then we know that the resistor is bad. So that's how you test a resistor. We'll test another one. These are new, so they will be within specs, so I believe they'll be all good. So that's 146 k ohm. So you've got k ohm or kilo ohms, and then you've got ohms. So 1 k ohm is 1000. And this one here is the last one we just checked. So that's 457.4 ohms. So if this was a 450 ohm resistor, then that's well within its tolerance to use again. Okay, and we'll move to a resistor now. Sorry, a capacitor. So a capacitor is almost like a battery. It stores voltage, it stores current. This one here, not that it really matters, but it's a 250 volt, 820 microfarad. Okay, and you can see its polarity. So that 0 will be its negative, which means that the other side is the positive. Okay, to test the capacitor, we push the yellow button on the multimeter. We want to access the capacitance range. So here you can see it's at 0 NF. It looks like a little n with a big F. So NF is microfarad. We get our capacitor. And to test this, we put our black probe here, where the 0 is, and this one here on the other side. So this is telling me that it's a 700, it's reading 786. The value should be 820. So that's okay to use. I'd probably replace it anyway. These things have a tolerance, which is usually in percentage, so some of them may be 5%, some of them may be 10%. Work off a 10% tolerance, and if it's within that 10% tolerance, then you can reuse it. Because what's the point in replacing a component if there's nothing wrong with it, you know? The last one is this one here. So that's for testing diodes. We won't test any diodes today, but I can show you what a continuity test is. So continuity is when you have a connection between one part of the circuit and the next, just like in a wire. A wire should have continuity from one end to the other, and when it does, you'll hear this beep. So that's an audio reference, just so you know that there is continuity. Sometimes you can't actually look at the multimeter, so you need a visual cue. So for example, if you had a wire and there was a break in it, you'd be able to tell just by measuring one side of the wire and the next, because it'll make this beep sound. So that's probably the easiest test that you can make using a multimeter. I guess the next thing I'll do is test some diodes, but that won't be in this video. But hope you've learned something. I'll try to post up more videos from now on. Just hit a little brick wall and needed to re-establish how I was going to do these videos. So I'm back online now. So thanks for watching, and hope